if you guys um, are doing the ACSL competition, or you want to do the coding competition that we're having, if you're new and you want to do the competition, just you can shoot me an email or just message me on Discord. But for those of you who are doing it, the second contest is due. Let's see, I believe it was March 7th. Here, yeah, the second competition is due March 7th. And Mr. Zarko just opened up the third competition, which is due April 11th. So we have a lot of time. We still have a lot of time for the second competition and a lot more time for the third competition, obviously. So you have until March 7th to take both tests for this contest number 2. And the topics for contest number 2 are, let's see, I believe it was let's see, yeah, LISP, bit, string, flicking, prefix, infix, postfix notation. So if you guys even want to take today and just meet in the Discord to kind of study together, if you already if you don't want to listen to what we're going over in today's meeting, which is Python object oriented programming. So very basic classes and objects and the basics of object oriented programming. If you already know all that stuff, you can, and you don't want to just listen to, you don't want to relearn everything, you can just, I guess, you can hop off and study, or just meet up in the Discord and study. I can join you guys later if you want, but that's what we will be learning today: object-oriented programming in Python. So I'll share my screen and we'll get started then. All right, you guys can see that, the PowerPoint.
Yeah.
All right, awesome. Oh, one sec. I have 2 monitors, so I think it's on the other monitor. Okay, there we go. So we will be going over object-oriented programming, as we said, in Python. If you guys have taken Java or Comp Sci A, you guys pretty much exclusively deal with object-oriented programming with your classes and objects. We have been we've been working on Python basics throughout the year, so we've been going over like how to declare variables, what strings are, what different kinds of variables are, how to declare functions, and that has all been under the kind of umbrella of functional programming. So OOP is object-oriented programming. OOP is abbreviated. So we've only been dealing in the realm of functional programming, which was your variables, and then you have your functions. I have a little comparison between functional programming and object-oriented programming here, so we can quickly go over this. But basically, when you have functions, as you know, you put in a parameter to the function and it returns something, or it does some action. For every output, for every input, there's only one output. If you want to look down here, I have some built-in functions that we've been working with. Absolute value, this is the power, and this is the sum. So if I were to do like absolute value of -1, it's always gonna return me 1, no matter, like, obviously that's the input, and it's always gonna return 1. It's not gonna return 5, for some reason, right? Or -1. You put in an input and it's going to return an output. And obviously we have variables and functions, and that's kind of what we've the two kind of you have the data storage part, and then the data you use that data to carry out some tasks. You manipulate it in some way, right? So these variables, they can be strings, integers, doubles, characters, lists, right? It goes on and on and on. But you assign something to the variable, and then you do something with a function by passing in that variable into the parameter of the function. So that is sorry, someone's calling me. But that's kind of what we've been working on for up until now. Data stored in variables, and then these are some examples. You put in the variable into the parentheses, and bam, you have your output. I know we have some new members, so if it doesn't really make any sense, or I'll kind of just quickly gloss over what we've learned throughout this whole time. You guys can go on to there's tutorials on the website, or you can email me asking questions, or just message me some on Discord or whatever, and I can go over everything we've learned so far. But that's all been under like functional programming, which it's very simple. It's manageable when you're first getting started. It's relatively easy to just read through the code, but when you get into higher levels, a lot of times you're gonna use object-oriented programming. So Python is an object-oriented programming language, just like Java, C++, C#, JavaScript, and Swift. So like already right there, you've got like most of the major programming languages that you're going to deal with, and they're all object-oriented programming. So we've only been actually dealing with a small portion of the actual functionality of Python. When you get into it, Python is object-oriented. So what we learned today is kind of the foundation of pretty much everything you'll do in Java in the future. And also sorry, did I say Python, and also obviously in Java you use a lot of classes and objects. So the new kind of, instead of variables and functions, we have what we call a class, which is kind of like a blueprint. You can imagine it, and inside the class there are methods which are similar to functions, but the methods are specific to the classes. So it's a little complicated, but we'll go over like a real world analogy to kind of simplify it. But just like this is kind of a comparison so you can see side by side. And then objects are instances of classes. So an object is really just something. If you want to think of it like that, it's when you think of an object in real life, you have like anything is an object, right? There's a monitor in front of me, there's a keyboard in front of me. You drive a car to school, you go to a school, you are a person. These are all objects. And when you're representing like real world objects per se, we'll get into it, but you need to store some kinds of data, right? There are attributes, certain attributes here that an object has. Say like I have a certain hair color, I have a name, I have a height, right? These are all attributes of the object of myself. So I am an object, if you want to think of it like that. And that's kind of what object-oriented programming deals with. That's a simplification, but it's just to, if you kind of want to wrap your head around what the difference is. If you want to think back to functional programming, what we've been doing, like if you wanted to create, if you wanted to model like a person, it would be more difficult, right? You would have to have either like a list or a dictionary, and you could have like a list of dictionaries for each person to like have multiple people, but it's not the most elegant solution. It's kind of difficult, right? So if you ever wanted to represent a real world person in a real world object or any object in programming, you want to use OOP or OOP OOP. So if you joined in during like the weekly coding sessions that we had before in the fall, you'll remember we learned about lists. And a list is an object, right? So it's built into Python already. But a list is an object if you want to think about it like that. And lists have methods, right? And if you look at these, there's a difference between the built-in functions, which are functions, and methods, which have to deal with classes. So if you look at, they're similar, right? They have the name of the method, the parentheses, but in the front, the difference is they are called on an object, and that's what separates a function from a method, because these ones you don't need to call it on an object. You just put in a parameter and it gives you an output. These different, for example, index will give you a different value for each different list, each different object, right? If you sum a list, it's going to give you the same output always. But if you put different lists here, and you want the index of, say, whatever value, it could be different for each list you put in. One list, your index, say of like the number 0 could be, like if you have a list of integers per se, the 0 could be in the beginning of the list, or at the end of the list, or in the middle of the list. It could change, right? Your output for this method is going to differ depending on the object you call it on. So that's kind of a side-by-side comparison. If you want to go into the benefits of object-oriented programming compared to what we've been doing, is you can use these objects and classes to represent things in the real world, kind of what we've been over. So you can have an apple has certain attributes. It could be yellow, red. It could have different, I guess you would call it varieties of apples. So different, I don't know if they were species, but different like breeds of apples, right? You have Macintoshes, you have Red Delicious, you have Fuji's, you have Granny Smiths. So these will all be attributes of an apple, if you want to think of it like that. And you can have small apples, large apples, rotten apples, fresh apples, frozen apples, juiced apples. Or I guess juiced apples would just be cider, but you know, the point is, an apple could be represented in a lot of different ways. And if you want to represent an apple in programming, you would do it. This is how you would do it. This is the easiest way to do it. So say if you wanted to create a program for a real world problem, object-oriented programming would be useful for you. And we'll go over another example in the future that's actually programming and not like having to do with different random objects. And if you look down here, like these are two of our coding club officers, so they're obviously different people, and if we say they are objects, no offense, they're people, but we'll say they are objects also. They have different attributes to them. They look different, different heights, etc., etc. And also, if you want a real world example of a method, like a comparison analogy to a method, which is, remember, if we go back, a method is kind of analogous to a function, but specific to a class. So if you wanted to have, say, a class of people or students, so in that class you would have different attributes representing the students, and under that you could say, because objects have functions, right? They have so they can do things and interact with things. Like my keyboard can type things, and my mouse can move the pointer, and Will Huang here can eat, go to school, he can take a walk, right? He's a person, so he can do things in real world, and that would be we could say that's a method. So if you kind of want to think of what we have done so far, we have the class, which is the blueprint. underneath we have the attributes, which is what like different characteristics some object might have, and under that we have the methods, which is what the what the what the object can do. And a lot of times the methods will be manipulating the attributes, the whatever the characteristics above. So for programming purposes, these are kind of the four pillars here: abstraction, inheritance, polymorphism, and encapsulation. So in CS and computer science, these are the benefits of object-oriented programming compared to what we've been doing so far. So I'll just quickly run through them, but if we can get into it, we're not going to get into these a lot today because they're more complex. But we will be able, we could do all of these in Python, and if you guys want to have like weekly coding sessions where we can just go through these, or even I can explain them in a general meeting, but they're a little more advanced. Abstraction is where you don't necessarily know what's happening inside of your class. For example, like I think in comp sci, the classic example is you don't need to know what is happening inside of your car. Like you don't necessarily need to know what the ECU is doing, what the engine is doing, what the thermostat is doing, right? To drive to school, you just need to know that you hit the gas pedal and it goes forward, and you can steer with the steering wheel. So I guess that would be kind of a real-world abstraction. But in programming too, you don't necessarily need to know what's going on inside of your class to use it. For example, if you were creating something and then selling it out to customers, your customers don't care, or they might not necessarily understand what's happening inside of the code that you've built. So you can object-oriented programming, you can kind of hide that away. You could kind of say, and that gets into encapsulation also, but you can kind of hide it away, and so that your end user can just have a nice simplified set of functions for them to use, methods for them to use. Like if we were to go back, I couldn't explain to you how absolute power or sum works on the binary level, because like programming, Python is a very high level language. If we were going to get down to ones and zeros, I would have no way. If I was looking at ones and zeros, I would have no way to explain to you guys what it's going on, and I simply don't know, and I don't, like, at one point I could perhaps know, but there's abstractions everywhere, right? You don't know the exact like binary level what's happening for, in even like a step above binary and a step above that, what's happening for append, remove, and index. But you don't need to know to use a list properly or to use these built-in functions, right? Because it doesn't matter. You want to achieve a certain task, and it lets you do it. You don't need to know what's happening on the binary level. So that would be an abstraction. Inheritance is simply you can have different classes inherit methods. So if I can have one method, I can have one class use another method from another class. So you can you don't have to like copy and paste the code. You can reuse code essentially. Polymorphism, you can have one kind of method do different things depending on the parameters you put in. And encapsulation is similar to abstraction, where you can have, if you want to think of it in Java, you can have private and public attributes, private and public methods also, right? Because you don't necessarily, it's also good for security reasons. You don't necessarily need to know the attributes of the values of every single attribute inside of your object. Encapsulation just keeps it nice. It keeps it private, keeps it secure, and that's one of the four pillars of object-oriented programming. And finally, if you're ever going to go into the CS field, or like IT, CS, software engineering, it's used by programmers. So just because it's used by everyone, you would need to know how to use object-oriented programming. So that's about it for the benefits and comparing it. Does anyone have any questions, or is it like, does it make sense so far? Does anyone have any questions? We'll jump into the actual code part, but this is the kind of computer science end of it. William, you want to add anything?
No, I think you got everything.
Yeah. All right. And like I said, we won't get into. I spelled this wrong. My bad. We won't get into some of these more advanced topics today, but we can get into them in the future if you guys would like to learn getting into deeper into object-oriented programming. But today, we will just be creating our first class. So does anyone want to, what kind of object would we like to make today? We can make a student, we can make an apple, we can make a banana. Because bananas are kind of boring, they're all the same. You can make a book. These are all real world objects. So we're going to represent something. Yeah. You want an airplane? That's fine. Okay. You want to make a airplane class. All right. Cool. That's fine. Let's see. I'm going to pull up some notes here. But I want to cover just these things in Python. So we'll run through the list. But is everyone kind of with me here? Yeah?
Yeah.
Alright, cool. Alright, so if you want to pull up PyCharm, or you want to pull up what was the other IDE we used to use? I bet I'm kind of losing it. But if you want to pull up PyCharm or your preferred IDE for coding Python, you can do that now. So we'll quickly.
This meeting?
Huh?
Are you recording this meeting by any chance?
Yeah, of course. Yeah.
Okay.
Yeah, I'm recording on my my computer, just so I don't have to deal with Microsoft Streams. It's kind of a pain. So sorry. But I'm recording it, so if you guys want to look in the future, we always record the meetings, so if anyone misses them, they can see them in the future. But yeah, I'll zoom in here. So first of all, we need to create a class. We need to create a blueprint for, in this case, we're not making oh crap. We're not making students. We're not creating student objects. We're creating airplane objects. So for class declarations, you capitalize the first letter. So that's how you separate a class from a like a function or a method or something like that. Your first letter is going to be capitalized. Class, and then for right now, we don't necessarily have to get into the insides of the class. We can just write pass, which will it doesn't do anything when you run the code, but it makes sure that it doesn't give you an error. So we'll just write pass for now, and then we'll give the, sorry, my bad, parentheses. Yes, parentheses at the end, just like functions and methods. We'll give the airplane some attributes. So airplanes have I guess you would say they have like a model name, like a model designation, right? Like a Boeing 737 or Airbus A330 or something. So we can give this is not inside the class declaration, but this is just showing that in Python you can, oh, my bad. Sorry, we're getting ahead of ourselves. So we've created the class, but now we need an object. We need the actual airplane. We need to represent the airplane in the code. And to create an object in Python, what you do is you create a variable. So we can call this airplane, we'll just call it plane 1, all right? And that's just a simple variable. That's what we've been dealing with so far. So yeah, just checking. Yeah, so this is just a variable. This is what we've been working with so far. Variables are going to stick with us forever. So Doesn't matter what you call it. And then when you create an airplane, you type out the class of the class of the object you want to make. And what this is doing, this is creating what you call an instance of the airplane class. So it's now we have a airplane object essentially. Plane 1 is an airplane object. Plane 1 is an instance of class airplane. Cool? That kind of makes sense? Yeah.
There's not supposed to be parentheses after airplane in the class.
Oh, my bad. Yeah. Right. Yeah, that's what I thought. Okay. Yeah, we're good. Okay. How's it giving me squiggly lines? Sorry, guys. Yeah, ignore the squiggly lines. They're just for formatting. It doesn't affect the running of the code. It does look kind of ugly, though. Anyways, we have now created an airplane object. Okay, so that's this step. And we can give this airplane attributes. Plane 1, and then we can give it we can give it an attribute wingspan, perhaps, right? Yeah, wingspan. And then we could say we can give it an integer, say like 100. Usually there would be a unit, but we'll just say it's like yards or something. We can give it like a model designation, right? And we'll call it a string. Going 737. What other? We could say a capacity for passenger capacity, right? And then what's the capacity of a Boeing 737? Like 150 people, something like that. But now we've given this airplane object some attributes, some characteristics that we can use in the future. But if you're thinking of it, this is obvious. Airplanes are real world things. In the future, you might not be building. You could be building like a button or something in a game, perhaps. Obviously, the attributes would be different, but this is just how you could declare them. And I'll show you in the future. There's a better way of doing it, but this definitely works. And say you want to know what the wingspan of our plane 1 is, you just do plane1.wingspan, and that will give us, I don't know, this is kind of small, but it says 100 down there if you can't see. So what this is doing is it's looking for the variable, and then that variable refers to a airplane object, and it's looking in the airplane object, and that airplane object has a wingspan of 100. So there you go. Now you can figure out what you can also do the same for model and passenger capacity. So that is giving an object attributes, and we can also give the object we can also give the object like methods. As I was saying, methods are what objects can do. So a simple one would be what would an airplane do in real life? We would say like fly from one area to another. So I guess if you want to make like a plane tracker, right, you would have to create another attribute. Yeah, you would need to make another attribute, say like location, right? Like where is the airplane in the world? You have the name, you have the passenger capacity. You could even make like an ID number, or like a flight number or something, right? If you were creating something in real life, to keep track of your fleet of airplanes. But we'll give it a location. We'll say I don't know, Chicago or something. But say perhaps that we wanted to create a method for this airplane so that it will we could change the location because airplanes fly around. That's what they do. That's the whole point of an airplane. So we need to be able to change the location. We need to have it actually fly somewhere. These ones probably won't change your passenger capacity unless you like change the configuration of your airplane, I guess. Won't change, and your mile designation won't change, your wingspan won't change, but your location definitely will. So inside the class, we're gonna create a method. So if you guys have done Java, we're kind of going a little backwards, I guess. We will get to constructors after this, but we're gonna create a method for our airplane class. So for methods, it's the same as functions. So you're gonna do just def for definition, and then def, and you're gonna do the name of the function. So I guess we would do like fly airplane, or name of the method, my bad, fly airplane. And then inside, you see it auto gives me, for the parameters, it auto gives me this parameter called self. And when you're using, this is different than for functions. You're always going to have a parameter self, even if your function doesn't, like if my function just said pass, you still need the parameter self. But obviously we want our function to do something, so we will give it a say like new location parameter, and then we would you would be able to set the, what you need to do is self dot location, and you'll get to new location. And you can even make this location, you can make these both location if you want, but we'll say new location just to make it less confusing for now. Why is it giving me a squiggly line? Yeah. But what this function does essentially is it self in Python is analogous to this in Java. So this self, this is going to get a little confusing. Self is going to refer to the instance of the airplane that we're calling it on. So in this case, plane 1 is the object. So self here is going to be replaced by plane 1. So it's kind of going to be the same thing that's happening down here. Essentially, this is the same function, right? This is doing the same. But you could just change the location using this. But if you want to say something else, like if you want to give the plane like a fuel, and the fuel is at like 22,000 liters initially, your function could change the fuel level to say like it subtracts, or like you multiply it by a half, right? Something like that, doesn't matter. Obviously planes don't fly with a full tank and then get half of the tank, or that wouldn't be efficient, but that doesn't matter. The point is that you have a you can write methods and they will do something to the object in question, and when you are referring to the object you use self. Does that make sense? It's a little confusing, but self is, if you want to think about it, it's being replaced by whatever object is being called on. So in this case plane 1, so plane 1 would be here, and then it would change. So we should be able to call this and it will work. So why don't we do plane dot, and then to call a method you do fly, oh my bad, plane 1, it's not, it's called plane 1. And if you look down here, it actually PyCharm gives it to us, so we could just click on it, and then we would have to set a new location. In this case you don't have to type anything for self, So we could say New York. And then down here we could print the new location, and it will have changed to New York. And if we print the new fuel, it will be now 1,000 liters, or 1,000. So that's kind of how Python methods work. You can create methods, whatever you want the airplane to do. If it was a student, you could have the student say its name, print out its name. My name is Kevin and I am 18 years old. I go to CB South. If it was a Apple, I guess you could say you could change the level of freshness of the apple, I guess. So you can go from from ripe to spoiled or something. I don't know. You wouldn't usually, create an apple, but the point is you can create methods to have the object do something. William, you want to add anything onto that? That makes sense.
Yeah, are you gonna do constructors?
Yeah, I am. I'm gonna get to that next, but
Okay.
yeah, I just wanted to go over methods because yeah, so we've done this, and this, so we're gonna go over constructors now. And a constructor is basically just it's a fancy method that does what we've done down here all in one step, and it makes our lives a lot easier. So say and the good thing about one more thing, the good thing about airplanes is, or classes is, and this is the main reason for using this. Otherwise, we could just program all of this into we could just make a variable for wingspan, model, passenger, location, fuel, etc. Right? We can just make variables if we were doing function programming. But the good thing about classes is you can reuse them. You can create multiple objects at the same time. So that's why I did plane 1, right? You can have plane 2. And you can give plane 2 its own wingspan. Not 100, we'll say 150. 150 yards or feet or whatever, right? Oh, sorry, my bad. You have to declare the object first. Obviously, you have to create the object before you give it attributes. But yeah, we'll get to a point where you can declare the attribute, and when you're declaring it, you give it attribute. Declare the object when you're declaring, give it attributes at the same time. But for now, just to show, prove a point, create plane 2 variable, and we make a new airplane object. And now you have 2 airplanes, because there's more than one airplane in the world. And if you're running an airline, you probably have more than one airplane. Otherwise, you wouldn't have an airline. So you need to create multiple planes. You would need to track multiple planes to keep track of your entire fleet. So instead of creating an entirely new variable or creating a dictionary of different airplanes, you could create a new object of an airplane, and that new object you can give different attributes to. So, and you don't necessarily have to do the same. Actually, Python's very flexible, so we could copy and paste just the location, and then the fuel capacity if we want to use our method. So we don't even need the wingspan at this point. So we'll say the location of this airplane is in Dubai, and then the fuel capacity, because it has to fly longer distances, we'll say it's 5,000 liters. So now you have 2 airplanes, and these airplanes have their own specific attributes. Plane 2 has its specific location, and plane 1 has its specific location. And you can now you don't need to create a new variable for each airplane you make. You can just create, I mean you do, but you don't need to make a new variable for its location, its fuel, and its passenger capacity. Now you have a way of kind of modeling all of this with a simple class, with a simple object. And then obviously these need to be changed to plane 2. But you can do the same thing that you did with plane 1. You can call the function that we created. So fly airplane, and then you can move this to Los Angeles, right? And right? So how you spell Los Angeles? Angeles, my bad. Okay, Los Angeles. So now we have this airplane has flown to Los Angeles, and plane 1, our original plane, has flown to New York. So if we wanna, we can print the location of each of our planes, and obviously they're going to be different because they're in different cities. If you look down here, it says New York and Los Angeles. So that's kind of the beauty of having an object. You can make different kinds of objects, and you can make a lot of them. You can keep on making them, and you don't need to create new variables for each one of them. You don't need to make separate variables for all of these attributes, because that could get really tedious really quickly. And if you were using a dictionary, it would be less tedious, but it wouldn't be as easy for people to understand, for users to understand. But now you have an ability to create different objects, and give them attributes. So essentially this is kind of slow. If you see, we had to create the object and then give it attributes. What we're gonna learn now is a kind of a fancy method. It's called a constructor, and the constructor constructs objects. See, so instead of having to create a airplane this way, there's a default. By the way, there's a default constructor. It's not written here, but essentially there's a constructor being called here. But we can create our own constructors, which is what everyone does, right? We can create a constructor so that we can both create the object and also give it values for all of these attributes at the same time. So we don't have to, this step is too tedious. And how we do that is with a special little function called init. And it goes, it's the same. You start with def, underscore, and it gives you this whole entire list. If you look at these, they all have the underscore, then a word, or the whatever you call the method, underscore, and then the self, the parentheses. So these are kind of fancy functions. They're special methods, special fancy methods. They are they have like assigned, like when I make def init, and then see, it kind of turns a different shade of purple. This is a special one. It has a certain kind of purpose, I guess you could say, and it's not. This one is not. It's not like what we've built. It's not one we've built. It's one that's kind of in Python that we use to do other things. I guess this is kind of like a custom function that we built specific to our class, but this init method is usable for all classes when you're doing stuff, and you're going to use init whenever you create a class, because that's just how, yeah, you're always going to have a constructor. You're always going to make your own constructor. So in this case, it gives itself here. You can actually change this variable self. You can change it to whatever you want, as long as you stick with it. See, it turns purple. As long as you stick with it as you work in the constructor, but we'll use self because it's a convention. So, and everyone else does it, so you don't want to confuse your readers. So we have this is just kind of how you create a constructor. In the constructor, you can give your airplane initial values, initial attributes. So what we had before was wingspan, model, spelled wingspan wrong, model, passenger, cap, and then location and fuel. So these are just parameters inside the method. It's the same as having like this here, new location. They just so happen to be the same. And then what we do to give the airplane like the attributes, essentially what we're doing is this, but up here we're doing this so that we don't have to do it in a separate step, and you'll kind of see what I mean later. But what's happening is we have we just need to assign the attributes values. So self is so that we're referring to the object that we're creating here, and then we can give it wingspan, right? So this, it's gonna be, it looks kind of confusing because these are the same name, but we don't have, this doesn't have to be wingspan, and this doesn't have to be wingspan either. It just so happens that, you know, we can make it like wingspan as long as you change this. But you're gonna want to name it wingspan, so when your person who's using your code is looking at your function, it makes sense to them. And these two are the same, that's why they're highlighted. This parameter is being assigned here, and then it's being assigned to the attribute. So if that kind of makes sense, these two are this is just the parameter being called, and then this is the attribute in the object. And then we can do the same thing for model and passenger capacity, and alright, should be the same here, and we can just keep on going. And this is location, and then, man, why did we do airplanes? There's so many attributes. We probably could get rid of a couple of these, don't really make a difference, but alright, there you go. That's your constructor done. So what we've created is, you don't need this. What we've created in our airplane class is a new method. It's a constructor method. And now what you'll be able to do is when you're creating an airplane here, you can give it values. So let's see. Why don't we do it for plane 2? We have already plane 1. So just to show you that it does the same thing as what we're doing here, we can give it some attributes. So it's going to be the same when you're creating the airplane plane 2 object. So airplane parentheses, and then in the parentheses you can give it all these values: wingspan, model, passenger capacity, location, and fuel. So we could say like 150. Model would be a Airbus A330. Passenger capacities is greater, probably like 350 people. Location is now in, where do we have it? Like Dubai. We'll say it's in we'll say London or something, right? And then fuel is 3,500 liters. And now what we've done in this line here is we've essentially done what we've done in these 6 lines. Basically we've cut down on our code, and it's doing the same exact thing as creating the object and then giving it different attributes. You can actually Python's really flexible. You can actually even though you have a constructor here, you can still give it another attribute, like what would be another airplane attribute? I don't know, speed or something. They fly at the same speed, but say it's like a propeller plane, so it flies slower. We can still do it like what we've done. You can give it another attribute, which is really flexible with Python, right? This would probably be in a string or something, like 450 knots. We've given this plane 2 object another attribute for speed, even though we didn't do it for plane 1 and we didn't do it up here in the constructor. You're usually not going to do it because it gets confusing. What usually when you're coding, you're not going to have you're not going to do any of this. Oh, not what I want to do. Comment that out. All you're going to do is just this line here, because it simplifies everything. One line, you created an airplane object and you've given it attributes. And obviously the airplane object is going to have the fly plane. So this, comment this out. If we do it over again, say plane 2 fuel, just to show it works. You run it. It's flown to Los Angeles, and it now has a fuel of 1750 from reduced from 3,500 liters. So that's kind of an overview. That's the very basics of those are the very basics of creating your objects. Does anyone have any questions? Does that make sense? I just talked for a while, so.
Are you gonna do set and get methods?
Yeah, we can do that.
I mean,
Yeah.
it's not really that important. But
Yeah, it's not because if you just wanted the fuel, you could just do this. But for encapsulation, yeah, you could create your own methods to print the fuel. And I'll show you like the print function later. So by the way, just a fun fact, if you tried to print plane 2, it wouldn't work. It wouldn't give you like all these nice little data values. It wouldn't say it's like a Wingspan model because it doesn't know how to. You haven't told Python how to print out a plane. All it knows is an object. So if you try to do this, it would give you a memory location. So if you want to look here, it doesn't print out the attributes of the airplane because it doesn't know how to, and it doesn't know what an airplane is. All it knows is you have an object called airplane in the class. But I'll show you how to configure it so that it does do that, and it doesn't give you a memory location when you try to print plane 2. And obviously that could be really useful to, instead of having to either go through and print each of these one by one, or to go through and use a get method for each of these. You know, that's obviously a hassle. So you could just I'll show you how to do a print, and that will print it out for you. So William, how would I go about? All right, yeah, let's make some get methods. Yeah, let me make sure I'm doing it right though. Okay.
You just like set them.
Yeah, I would have to create a separate one for each of the attributes, correct? Yeah. So it's kind of a hassle. Yes. Okay.
So,
yeah,
like,
essentially.
Usually you don't go into like you have to do these get and set methods because you don't want to access the attributes like directly.
Yep.
With like plain dot something, because that goes into like privatization, and like it's not really as secure.
Yeah, exactly. So what William is saying is we could create a method to get the wingspan. Instead of accessing it like this, instead of going into the airplane and then doing the attribute plane and then its attribute dot wingspan, you could write a method so that you could just get the wingspan of the airplane, and it would just return self dot wingspan. And then you could do this for each of your attributes. You go down model, passenger, location, etc. And what it's doing is, say we wanted to know we created an object, but we don't remember what the wingspan is. You could do plane 2, and then remember dot because you're calling a method, and then get wingspan. And obviously you could assign that to a variable or something. We'll just print it out. And if you see down here, it says 150, which is what the value we assigned it. So yeah, all this method does is it goes to the self, and it returns the object's wingspan, which is what self is. And then you can have a setter too. Set wingspan self, and then all that would do is it wouldn't return anything because you're setting something, you don't need a value. So, oh, my bad, you would need a parameter here. So the new wingspan will say, you can make that wingspan, it's up to you. Okay, and then you would just do self dot wingspan which is the attribute, and it gets the new wingspan. So there you go. It's hollering at me because I don't have enough spaces, I think. But if we go down here, where were we? Yeah. So we could say plane 2 dot set wingspan, and then we could set the wingspan to your wingspan wouldn't change obviously when you're making a plane, unless you like, I don't know, change the winglets or something, but you could change it to 125. Say the wingspan got shorter for some reason, and then it's now 125 down here. So what we've done is we created a set method, and then we called the get method to get the new value that we set. And it's kind of doing the same thing here, but as William said, you might not want your clients to go in and have access to all your attributes. So this is a method just to get it, and then set it if you want. But this is the same thing as what we've done here. This would be a set, and then to print it, you would just do print and then put this inside the print. But yeah, you have a constructor, get, set. You have your own function. So those are kind of the basics. We can do a print. Let me just see how I did it here. Yeah. Yep. Okay, gotcha. Okay, so we can go into another special function from this special method. Sorry, functions are for something else, but special method. So it would be what's str? Yeah, str for string, I assume. So now you have a. Now this is gonna allow you to print, and it's giving me. Yeah, so I think. Yeah, these are all the built-ins, but if you want to check it out, essentially what we're doing is we're changing the built-in function because it has a built-in one, but we're now gonna override it to create our own string function. So you might want to. So this would just return. You could say like you probably want to do this with f strings, but we'll just do it with concatenation, or yeah, with concatenation, just to so it's easier to see. But the wingspan of the plane is, and then you can do self.wingspan. The model is, and then you just do self.model, and then you could have, I don't know, the location. We don't have to print out everything, but you could theoretically, right? Let's not do that. All right, the location is self.location. Yep. Okay. So we just created a new kind of print method, and if we want to call that on our plane 2 down here, say we've created a plane, we don't need any of this stuff anymore, so we'll comment it out. But remember when we used to print, it would give us a ugly squiggly, it would give us a bunch of symbols as the memory location. Well, when we print the plane now, it should give us what we created. Oh, my bad. I spelled wingspan wrong again. Oh my god, it's like the 3rd time. Okay, let's try that again. Non-string type tuple. Okay. Yeah. Yeah, you know what? We'll just to be careful, we'll turn these into strings. model is already a string, so we don't have to worry about that. Yeah, like I said, you in this scenario the go-to would just use f strings, which I think I've explained in the past, but we could go over that in the future or after this if you want. But you would use f strings for this. You wouldn't like concatenate it. This is kind of a clunky solution. All right, this should work now. Yep. Oh, need some spacing here. So essentially, now that we've created our own print function. Whenever you print it, instead of giving us a memory location, it will print whatever you want it to print, and what it's overriding the original print, essentially. So the wingspan, I spelled wingspan wrong again. Oh my gosh, this is terrible. All right, there we go. The wingspan of the plane is 150 feet. The model is Airbus A380. The location is London. Okay, so now you can print out your function however you want. You could change this to whatever you want. Like I created a card class in Python, kind of similar to what we did in CSA, and my print is a little more complicated because it's going through the deck of cards and printing out each card. So if you guys want to do this in the future as like a side project to create a card class, we did this in CompSci A with Mr. Zarko, but that was in Java. This is in Python. I just converted it into Python. You can see you can do whatever you want for your prints, and for your constructor, it doesn't have to be so bland like we had here. You can have more complicated constructors. You can have all kinds of different methods that you can create, and then you can create different classes on top of each other. And if we want to go into more of that more different stuff, that like the 4 pillars of object-oriented programming, one of them is inheritance, right? So this would be an example of inheritance. Like you can create, I mean, what inheritance is, you have parent and children classes, and they inherit the functions. So for example, like we have the keyword super here. So like a square is a rectangle, right? So they kind of, I guess you could say the square class inherits the rectangle class's methods. So that's inheritance. But for what we've done is the very basics. So we have a constructor, we have class, we have even a print function now, we have fancy methods, we have a getter and a setter. So yeah, those are the basics. Does anyone have any questions? I think we'll end it there. That was kind of long. It was an hour. That makes sense for object-oriented programming. It's different than what we've been doing. And for example, what a application in programming, this is kind of a more abstract application, but a real world, an actual like application that you might want to pursue in the near future is, let's see, open. So I made a tic-tac-toe game, right, with Pygame, and it was a hassle because I was going through and doing the functional programming because I wanted to keep it like simple, but it ended up not being simple because I did it that way. Where was it? Sorry, this is the wrong one. Open. Okay, where were we? Open tic-tac-toe Pygame. So run this. All right. So if you look here, these are all just functions. There's no classes. There's no objects going on. This is functional programming. Right? We have functions, and then we just have a bunch of different variables. And this can be far simplified if you use object-oriented programming. You could create a button class for each of these boxes. And then in that button class, you could have, say, like a location attribute, or in a value attribute, like a X or an O attribute. And then you would very easily be able to set up a grid of those with like a list or an array or something, right? and like a list of these button objects that have their own attributes, instead of having to do it with all kinds of different variables and functions and trying to figure it out, you can just create buttons, and then that would make your life a lot easier than what I created. It like kind of object-oriented programming is nice when you want to represent like a real-world board that has separate, different. You could create a button class and a board class and whatever class, right? So that would be like a programming application if you want to wrap your mind around that to start off with. But yeah, that's object-oriented programming. Anyone have any questions? It's kind of a while, so I don't know if you guys are still with us.
Still with you.
All right, but yeah, that's about it for today's meeting. Then we will, if you guys want to have, we can have like a weekly coding where we go more in depth, but that's the basics.
Thank you, Kevin.
Yeah, so if you guys want to hop off, it's been a while, so